Cool. So I will try to keep the slides to a minimum, but I just kind of want to set the context. I think Dave covered it pretty well in terms of how broad sort of the platform is and where we've kind of focused up till now, really on client experience and performance. And with sort of one of the big things that we wanted to talk to you guys about being IoT analytics, IoT management, security, inventory, and things like that. And so that's probably where I'm going to focus. But if you guys have any questions or want to interrupt along the way, definitely do so. So just a really quick thing on what sort of motivates this. You've probably heard this and lived this. I don't want to belabor the point. But there's just an explosion of IoT devices, especially in certain verticals. So manufacturing, healthcare. But we see it in enterprises, too, with smart lighting and, all sorts of random things, actually. Across our customer base, which sort of spans these things, we've seen IoT devices like, it's Valentine's, right? So there's something called a love box that we've discovered on some customer environments, where you can text someone a message, and on their desk there's a box, and the box starts spinning when you get the message, and the message pops up on top of it. There are IoT devices we've seen in healthcare networks. Tesla cars join the corporate network. We've seen Ford cars join the corporate network. We've seen things like a device where, again, Valentine's, if you're thinking about someone, you put your hand on, I guess, like a device, and a bulb sort of lights up in front of them or whatever, and then they can do the same back to you. And obviously, these devices, as we'll kind of talk about, they're not built by networking vendors or security vendors, obviously, right? So there's a lot of, both from a networking as well as a security perspective, performance or security perspective, there's a lot to be desired with these kind of devices that are just showing up more and more so on networks. And to David's point, just because we have such a big customer base already, we can actively see what's going on, and it's one of the motivations that sort of brought us here. But yeah, that's basically sort of the motivation in a big way. We see more and more of these IoT devices in certain verticals like healthcare and manufacturing, as an example. These devices tend to be critical devices, not like the examples I just gave you, but infusion pumps, EKG machines, ultrasound machines, where those IoT devices, if they go down or if they're unsecure, that's a big problem for the organization. Or in manufacturing, robots or tools or cars or things like that, which again, if they sort of stop, that's a direct hit to the line of business, right? So there's sort of critical IoT devices, there's non-critical IoT devices, but of course these things all share the same network substrate, and that's what makes sort of this problem worse and worse. And so, just to kind of set the stage as to what we've always done and why this is such a natural progression for us in terms of looking at IoT devices. This is the world for us. It starts from client devices and ends at applications. I think David called it out before. The data center is a black box to us. So we are not an application performance management company. So we don't look at database transactions or anything like that of applications. It's just the clients, as they connect to wireless or wired, as they get authenticated, get an IP address, get DNS, as they get out to the wide area network, and they access applications. It's the access network sort of which sort of we look at. And what we've done is we've sort of built, there's a ton of data, that's kind of what this shows over here, that emanates from the access network. And what we've done is is build a platform that can ingest different pieces of this sort of client access network puzzle, right? And so if one of those pieces is network traffic. So I think David said this, but we have a collector that can process network data and sort of retrieve information like, what are the client devices on the network? Identify them. Is this an infusion pump? Is this an iPhone? Is this whatever it is? What applications is it accessing? What protocols is it using? What's the results of those protocols, and so on? And we've always done this for the use case of performance, but I'll sort of talk beyond that as well in this presentation. From the network itself, the network infrastructure. There's data from, for example, the wireless LAN controller. So this, in addition to the packet data, can give us information like, well, where is this client located? What access point is he connected to? What's the signal-to-noise ratio? What's the interference level at the different access points, and so on. So it gives us the wireless state and a notion of location and mobility for these devices. We collect data directly from applications, right? So Citrix is a good example that David brought up. Skype for Business, Cisco UCM. In certain verticals, we've kind of focused. So in healthcare, GE Health is another data source. Clinician communication devices, certain ones of those like ASCOM and Mobile Heartbeat are data sources we can process, and so on. And so that's data, again, that gives us that part of the picture of the clients. Like what's their application experience and what are they doing in the applications. We collect data from network services. So Syslog data from Radius and DNS DHCP, which can give us additional fidelity beyond the packet data. So with the packet data, we can tell that a Radius transaction took a long time, or it failed, or it got rejected. But from the Syslog data, we can correlate that with what was the exact reason code as to why it failed, and sort of get that level of insight. From the routers, we collect NetFlow data. So again, this gives us that additional client picture of, okay, well, we know where the client was located. That, for example, comes from the wireless side. We know what the client was doing. That comes from the packet data. We know any kind of network service interaction. That comes from the syslog, as an example. We know what router interface and what service provider its traffic is going over. That comes from NetFlow data from the routers. And then finally, the application side, we can get that directly from the application, or we can get that also from the packets. And so basically, it's sort of an end-to-end picture that we're collecting about every single client device in every single enterprise network that we're in.
So on these public clouds, are you in their data centers, or are you just seeing it from my network's perspective going through your appliance?
It's the latter. So we're seeing it from your network perspective. Okay. So it's all your access network. And so our crawler or collector basically sits in your access networks, looks at layer 2 traffic of both your wireless and wired devices, and basically correlates it with all this additional information. But it's all client-centric and access network-centric. Yeah. So cool. And then the very last data source here is an optional data source, which is sort of more geared towards performance. When people really, really want to get that client perspective, you can put a piece of software on a client device, Macs, MacBooks, Windows, and Android. We talked about this last time, I think I was here, where they can run synthetic tests, and that data can feed back into the platform as well. So really, if you think about this, this is a holistic picture of every single client device in the network. And up till sort of probably about a year ago, we really focused on performance. We wanted to focus on what was the client experience of every single client device, and when those clients were having issues, where were problems happening? How do we give recommendations as to improve client experience? How do we baseline? How do we predict what the benefit will be? Those kind of things. That's kind of where we've been focusing on. As we've gotten more and more traction in verticals where IoT has mattered, basically what's come up is that, well, you guys are seeing all this data, and you see all our IoT devices. We like the fact that for our IoT devices, we can tell what they are and what their performance and connectivity is like. But then how about behavior? How about security? How about detecting when things these devices are misbehaving? How about actually going and securing those devices when they do so? Those are use cases that we've heard often enough across our customer base. And again, because we have all this data, we can actually see some of this happening in real time. We can see some of these devices misbehaving in some of these ways. And that gives us the insight that, okay, this is a real problem, and it's only growing just because we see the number of IoT devices grow across our customer bases.
What do you mean by misbehavior, and how would you identify it?
So, okay, hold that question for a couple of slides. Basically, there's going to be a lot of focus on that, right? Because it's very different for an IoT device to misbehave versus your laptop misbehaving. The latter is a much harder and more general security problem, which we don't try to tackle. The IoT device problem, the way we see it, is sort of a far more scoped down problem because they're sort of purpose-built devices that we can baseline and characterize what they do. So, but I'll definitely talk about that some more.
So what kind of devices does your client agent support?
The client agent supports user devices. So on the IoT side, it doesn't really come into play. It's just for completeness, I just wanted to cover the fact that we can ingest that data as well. But it's really much more from a performance side of the house. Windows, MacBooks, and Android devices. So you can put agents on that and they can just run tests against the network. But obviously, one of the other things about IoT that's special is it's not like you can put an agent on an infusion pump, right?
Right.
So, cool. And in general, we're multi-vendor across sort of what we look at as the stack. So from the client all the way to the application. You know, if you look at sort of what Radius servers, for example, that we support you know, Cisco ICE, Aruba ClearPass, Microsoft Radius, Free Radius, right, across sort of the most popular Radius servers across our customer base. We're working on Forescout as another example, right? If you think about wireless at that layer, we support Extreme Networks, Cisco, Aruba, right? So again, sort of multi-vendor across each of these layers. And our thing is, what's the customer problem at the end of the day? And typically across, you know, network infrastructure from, you know, wireless to network services to switches, routers, firewall to applications, nobody is single vendor, right? It doesn't even make sense, right? And so for us, we want to collect all of this data regardless of the vendor to get the proper picture around the client devices in the environment and actually build that up and be able to analyze it. So, cool. So, you know, this is sort of just a quick point around sort of further kind of getting into, well, okay, we're doing all this network analytics around client devices and client experience, but why does network analytics and IoT analytics, how do they sort of work together? IoT, you know, inventory, performance, connectivity, behavior analysis, security. Why do those things all kind of fit into one sort of package? The main thing is the data collection, which I just sort of talked about. But the other side of it is that the special nature of IoT devices in particular is that they're purpose-built, right? So they have a defined purpose that they're supposed to do, right? An infusion pump shouldn't be talking to Facebook, as an example, right? It should just be talking to its infusion pump servers, collecting that, and you know, maybe Radius, DNS, DHCP, and that's about it, right? And that's its purpose in life. You know, glucometer has a different kind of purpose. You know, even an Alexa to some point has a certain purpose, but of course an Alexa's purpose can be quite broad as compared to some of these other devices, which are more narrowly focused. But there is a purpose behind these devices. Secondly, you can't put an agent on them. So they're very hard to sort of monitor from either a performance or a security standpoint, in the sense that it's hard to put antivirus on these things. It's, so really, you know, a lot of the times with these devices, the only sort of knowledge of what they're doing comes from observing their transactions on the network. So it comes from staring at, you know, just sticking with the infusion pump example, what the infusion pump is doing on the network, right? Who is it talking to? Is it talking to someone that it never used to talk before? Is whatever it's talking to sort of deemed bad and things like that? And that's sort of a special characteristic of IoT devices that's not the case for general user devices, right? Where there's just a lot more options. And obviously, in the security side of things, just a broad swath of solutions or whatever to help secure user devices. The second thing, I think I mentioned this before, the vendors who build IoT devices are not networking or security vendors, right? And we see this all the time. They use cheap chipsets, right? So from a wireless standpoint, their connectivity is terrible. A lot of the times they'll join sort of inefficient networks. They'll roam in a really weird way. From a DHCP or DNS perspective, they'll do some really quirky things. Just yesterday, actually, it was in an environment, we saw like a Bose smart speaker basically do DHCP like every 30 seconds and just keep getting new IP addresses. So the DHCP server would just keep giving it new IP addresses. But we saw this sort of happening for sort of days on end, right? And it's just because, again, that these devices just have non-standard standard behavior. And again, on the security side, a lot of these devices come with default passwords. I'm sure you guys have heard all sort of the famous kind of Mirai botnet or like the DOS attack against the Dyn servers and things like that have happened via IoT devices, just because, again, from a security standpoint, they're just inherently insecure devices. Sort of security is kind of an afterthought, default usernames and passwords and so on. And so that's the other side of it. And then third, it's the point about network behavior, right? That because of the first two facts, and because these are purpose-built, and because you can't put an agent on it, the network behavior is sort of critical to understanding these things. And critical also because you would expect that network behavior to be predictable for IoT devices. And this is sort of the big critical difference between a user device and an IoT device. If you on your laptop or on your phone went to some site you had never gone before, that's probably normal behavior, right? Maybe you just want to go, I don't know, research Russian literature or something like that, and that doesn't mean that a hack is emanating from Russia, right? So, whereas an IoT device, if an infusion pump started going to a site that it never went to before, and it was the same kind of deal, that's something that you would find very, very interesting and suspicious as a network or security operations person. So that's kind of the big difference, and that's sort of how we see kind of network analytics and IoT analytics kind of come together, but not necessarily network analytics and just a general security problem, right? It's really very specifically for IoT devices. And it just so happens also that IoT is sort of in people's minds and both in sort of hype, but also very much so in reality, that we just see this really happening on our customer networks.
So it's one thing, one of the things that you see a lot in the IoT space is you see a lot of these security plays come up and say, hey, we're going to secure your IoT devices, and that's important, and we think that's important as well. However, there's a lot of money being spent on line of business devices across all these different industries, whether they're robots or all the stuff in healthcare that he's mentioning. And if they can't connect to the network, then they're useless. You're not getting a return on your investment, and they're spending a ton of money on these devices to drive a certain business goal or business revenue, whether it's top line or patient care or what have you, or producing cars or what have you. If these devices can't actually communicate and behave properly with the rest of your network, then security then becomes not even relevant. So it's our understanding and belief that just taking a security focus is nearsighted. So we believe that not only do you have to look at the behavior of these devices, understand where they are, what they are, how do you classify them, and how are they behaving with the rest of your network, but then once you do that, okay, now then, how do we go about securing those devices, or how do we tell if there's threats that those devices might present in terms of their operation? But you can't just take a one siloed view, because really, if you're going to install or put in a system just to look at IoT, you're creating yet another silo in your network, and another silo that has to be compared against everything else in your network, and it becomes really difficult. So we truly believe in context, being able to understand how every device and user operates in the network across the entire network. So that's something that's unique to us.
But there will be hundreds of devices, and every device will have its own purpose built by different vendors. So how do you plan to solve that problem of fingerprinting each device, right?
So awesome question, actually. So I have one more slide that I'll actually show you. And it really comes down to automatically learning. This is where machine learning and big data really comes into play. Okay. Because beforehand, we have no idea that new IoT device, new model of EKG machine comes up. We have no idea how it's supposed to behave in practice. And for us to go and catalog every single one, whatever, we can catalog it to the point of identifying it. That's really useful. But cataloging its behavior is not going to be practical. So that's where you need algorithms to actually automatically learn it in your environment. You need algorithms to learn what that same device behaves like in other similar environments, right? You need to understand how that behavior changes over time. And then you can sort of figure out what is an outlier or what is an abnormality versus what is normal. But that's the name of the game, actually.
Can I add something to that?
Yeah.
Also, because we're looking at hundreds of customers, if we see something, if we see an IoT device and we classify it and identify it at one customer, we can take that learning and say, oh, we're seeing that here and here and here and here, and it's kind of like a snowball rolling down a hill. And that's something, because we're cloud-based, that other folks can't use. Now, not only do we apply algorithms, machine learning, and AI algorithms to automatic classification of these things, but we're also learning from what we see in other networks, and we can apply that across our entire customer base. And when you're talking about 17 million client devices, you can learn a lot fast, and our customers benefit from that. They don't have to do anything. Because we see it, we can say, okay, we saw that here, that's what these are here, and we can, and they reap the benefits of that, basically. Make sense?
Yes. So this next one is the last slide that I have, and I just want to transfer over to actually showing you this stuff, versus sort of sliding you guys to death. So David alluded to this earlier, right? What we've heard from customers in terms of their use cases around IoT go way beyond just securing them, although securing them is extremely important and is sort of a critical aspect of it. But the way we've sort of seen it, and I called it sort of the operational life cycle over here, right? But where it starts is inventorying, first and foremost. So what is on my network from an IoT device perspective, and where is it located? And even questions like, how often are they on my network, how active they are, and things like that. From the perspective of, I bought all these robots or in-touch telemedicine robots as an example, right? I bought 300 of them, but I only see 25 of them on average active or whatever it is. Can we do something there? They were very expensive, right? But the other part of it is we see a lot of IoT devices join networks that either are unsanctioned, right? I mentioned like Tesla cars joining like corporate networks and stuff like that, right? Which, you hope that they would be on the guest network, right? Or bought by line of businesses without necessarily consulting IT, right? Or bought by previous line of businesses and are just kind of still hanging around. So we get a lot of like, a simple one that comes to mind is Amazon Alexas, right? Or any kind of smart speaker for that matter, right? So whether it's Amazon, Google Home, Bose, whatever it is. But these are listening devices at the end of the day. And there are obviously in healthcare, there are policies against that. In finance, a bank customer of ours, all of a sudden saw a bunch of Alexas in sort of their corporate network and their environment. Actually, it was on their guest network, but it didn't matter. Because nonetheless, basically this was listening to potential financial information that was being discussed by people, right? So just even in cases like that, you sort of see, these devices that you don't think are sort of problematic or anything like that, or you don't think they even are on your network, but in actuality they are. So the first step of this is sort of inventorying this whole, set of these, a subset of which you'll care about, right? In the healthcare example, or let's say in the manufacturing example, you'll care about the robots, you'll care about the tools, you'll care about, the devices themselves, the PLCs and things like that. But what you don't necessarily care per se, you don't care about the performance or anything like that of the Alexas and the Google Homes and things like that. But you want to know about them because you may have a policy against them. They may be screwing other things up. They may be vulnerable to being compromised in a way that can affect the rest of your environment.
And today, a lot of this is manual. A lot of our customers are doing this manually, and it's a pain in the ass. You'd be surprised, maybe you wouldn't be surprised, you'd be surprised at how simple. I mean, they're literally having spreadsheets just trying to keep track of IoT devices. What they want is they want to be able to go to a page and have a system that can tell you, okay, here's the inventory of what we've seen. Here are your glucometers. Here's the VLANs they're on. Here's the SSIDs they've been talking to. Here's the host IPs, the destination host IPs they've been going to. Here's how they've been behaving so that you can understand their behavior and then take action. It's not even a security issue at this point. It's just simple, how do I get my arms around where are these things? What are these things? What level of software do they have on them? What SSIDs are they talking to? So I can actually control and put policies in place to do something about that in the event that there's a problem. Because these things cost so much money and they're tied, again, directly to some specific initiative that a company has. For example, with Tesla, if they're IoT robots, they literally have these Bosch tool wrenches. They're huge, Wi-Fi connected things. They're torque wrenches. They use them on the line. And they connect via Wi-Fi to APs. If these things get sticky with an AP, and for some reason production goes down, there's a tangible impact to that. I mean, their production line suffers. Their production suffers. So it's kind of like BYOD on steroids, but without even being able to keep track of, with BYOD, at least at least the universe of devices that are going to be on your network because they're fairly well known. In IoT, it's 10 times that. And IT guys just cannot. They're not data scientists. They can't keep up to date on how every single IoT device behaves with every single part of your network. We can. And they really just want to automate this so they don't have to spend time, hunting and finding and fixing problems. Sorry.
Cool. Yeah. All right. Thanks, Dave. So, okay, the second aspect of this, and sort of David alluded to this. Okay, so now that I know what these are, for the subset that I actually care about, that are actually critical devices tied to line of business, tied to, very expensive usually, right? Can they even get on the network? So can they connect properly? And can they do the function that I bought them to do, right? Can my telemedicine robot be able to sort of show its screen and have the doctors able to do telemedicine, right? Can my infusion pump be able to talk to its server and therefore get the right configuration in order to operate properly? Can the torque wrench that David brought up, can it communicate so that it gets the right recipe as to right pressure that it needs to tighten the bolts to, and also be able to communicate that back? Right, so that's sort of the next step. So there's inventory, but then there's just the basics of, can it get on the network, can it connect, and can it do the function that it means to do properly?
So I think you guys have done a great job communicating the problem that you're
Yep.
looking to solve as well as the solution. Do you have any kind of real world examples, maybe not on the IoT side,
Yep.
because I understand that's new, but just the traditional Voyance product of how it's helped some of your customers find issues and then remediate issues they wouldn't have been able to otherwise?
Yeah, no, I'll actually show you. So this is the last slide. I'll actually show you a demo of both the IoT side and the Voyance side, but centered around IoT and centered around real-world examples.
I have one, just quickly. I was up in Vancouver seeing Lululemon, the Lululemon folks, they're customers of ours. The IT guy there was having issues. Their users were calling, complaining about poor web performance. He didn't know then that the users always do the same thing. Oh, you have shitty Wi-Fi. It's lousy Wi-Fi. Can't connect via Wi-Fi. What he found was he had a firewall problem. He had daisy chain firewalls. It was an architectural problem. And there was delay in getting through those firewalls. It was causing performance for a certain amount of users. We were able to see that. And then he was able to go and rectify that problem and take away that problem that would have caused him probably a week or 2 weeks to even solve. But when the problems crop up, they're not immediately identifiable in terms of what the root cause is. We kind of sift through all that. So we were able to see, you have HTTP performance problems, port 80 performance problems, but it's not coming from web response times, because web response times are good. It's not coming from your client devices. Your Wi-Fi connectivity is good. We found that they had, again, put two firewalls right in line with each other, and that was something they didn't want to do and they weren't aware of. So remember I told you about that single source of truth? One of the neat things about this particular platform is that because, there's usually in our organizations, there's a guy that runs wireless, there's a guy that looks at desktop and clients, there's a guy that looks at routers, there's a guy that looks at wired, there's a guy that looks at apps, there's a guy that looks at the WAN, and they all use kind of different tools. And if there's a problem, you get this. Oh, it's your problem, it's your problem.
I've never seen or used your product. Can I actually see it?
Yeah, exactly. That's where I'm
This helps alleviate that problem.
Exactly. Yep, for sure. So this is, if you bear with me for like a couple more minutes, I'll actually switch to the product. So the second step, connectivity and performance. The third step is where we sort of see it as characterized behavior. So what exactly so now that they can actually get on, now I need to start worrying about, okay, what exactly are they doing? What does normal behavior look like for these devices? And start to automatically learn that for a given IoT device type and model. And again, not only in your environment, but also in other environments. Then sort of you get to detecting issues when these devices misbehave and securing these devices, right? That means programming a radius server to de-authenticate or change of authority these devices. That means programming your firewall with an ACL or your switches and routers as well with those rules in order to sort of mitigate this problem of these IoT device compromises spreading to other areas. And then finally, there's sort of the verify that it worked, right? So whatever we did to secure these and mitigate the problem, actually sort of verify that that actually worked, and prevent. This is where segmentation and microsegmentation comes into play, where whether that's sort of, the segmentation thing is just make sure they're not sharing the same VLAN with, an Xbox or something like that, or, user devices, or an SSID and things like that. Microsegmentation in terms of software-defined networks, software-defined access. In terms of being able to put policies around groups, these groups shouldn't communicate with these other groups, and these groups should be isolated and so on, and be able to sort of verify that that's actually the case.
Does your product actually know what those microsegmentation policies are and then alert on that?
Yeah, no, well, we read the policies, right, from like things like the radius server via like pxGrid and things like that, right? So we read all the microsegmentation policies. Today we sort of give you visibility as to, well, wait a minute, these were your policies, but this is actually what's going on in the environment. Some customers sort of have asked us, hey, if I want you to alert me whenever this policy is violated, as an example, right? First off, we've kind of taken the tack of, okay, we want to learn what normal behavior looks like and only alert you when it becomes abnormal. One of the other use cases, well, okay, no, that's great, but I also don't care about abnormal and normal when I have a policy that has to be adhered to. I want you to alert me immediately. So that's the other side of it. So awesome. So let me stop here. This is my last slide, and I'm actually going to switch to the product at this point so you guys can actually see it. But any sort of thoughts or questions around, do you guys see these use cases coming up more and more around IoT in the environments that you manage?
There are some, yes. So I mean, we're seeing it more. I'm not seeing it everywhere, but it is starting to crop up.
Okay. Gotcha. Anyone else sort of see kind of?
In my industry, it's a lot of home-based device.
Which one, sorry?
In the industry that I work,
yep,
we have a lot of gaming console.
Okay. Yep.
And these are the words for network, especially on Wi-Fi.
Of course. Yeah. Exactly. No, I mean, that's the thing, right? A lot of these IoT devices are just like Xboxes and PlayStation 4s and whatever else. And they're problematic for the environment. Or sorry, not for the environment, for the networking environment. Just by bandwidth usage and everything else. So
are you guys looking at all or going to try to do any kind of SD-WAN analytics?
Yeah, so we read NetFlow data today, right, from the routers to just give a basic picture of interfaces and service providers and how traffic is getting routed that way. The SD-WAN step, as we see more and more adoption, which we are seeing, would be to sort of not only get the NetFlow, but also get like the SD-WAN configurations and the overlay networks and things like that to be able to tie those together. But that's sort of the WAN piece of the puzzle, if you will. Yeah. Actually, I just realized the screen's not switching. 1 second.
You had asked about kind of a real-world example. Another one that's kind of interesting but not readily apparent is we've had a lot of customers of ours, a lot of them are large scale. They've got 15,000 wireless users and 8,000 access points, and they get all the time they get calls from their clients or their end users saying, hey, I have poor Wi-Fi experience. And so once we pinpoint where that poor Wi-Fi experience is coming from, because we baseline everything, every transaction, every client transaction we see, because of that baseline, if you make any changes to your network, whether it's Wi-Fi or any other part of your network, we actually log that on the baseline. And you can actually see if a change you made, I made a code change to my WLC. Did that make an impact to end user performance? So what Notre Dame was able to do, for example, is they were looking at trying to understand how to improve poor Wi-Fi experience in a given area. So we baselined that area for them, and they were able to see it, and then they said, okay, I want to make this change. Once they made that change to the network, on that baseline, we annotated that change so they knew exactly when it happened, and they were able to see over time, did that change have a positive impact, no impact, good impact, or bad impact? And they were able to basically quantify that change, and that's something that's really useful in justifying, infrastructure expense. Really, because vendors always, especially Wi-Fi vendors, the 3 to 5 year refresh cycle. Well, we can tell you with real data if that's going to be useful or not, just as opposed to just doing whatever the vendor tells you. So, and that's come to be really useful, not just in Wi-Fi, but across the entire network. Where do I need to add capacity? Where do I need to look at where's my WAN link utilization having problems, so I can actually justify expense as opposed to, gee, a bunch of people are complaining, maybe I ought to take it to 2 weeks to look at it. So that's another kind of value of the product.
So what I'm going to do in terms of the way I'm going to show you the product is different from the way I usually show the product, where it's sort of start from a network engineering use case, start from a very broad general use case about client experience, and then sort of show like some of the what do you call it, like the specific use cases where IoT devices and things like that. What I want to really focus on here, just because this is new, just kind of wanted to get your thoughts about it as well, is focus on the IoT lifecycle that I sort of talked about, right? So inventorying, performance and connectivity, characterizing behavior, detecting abnormalities, securing, and so on. So that's kind of where I wanted to focus. This is a live environment, just completely anonymized. So it's a hospital, general hospital. Right? Back to the 80s references. Right, so, and basically what you're looking at here, just some high-level stats around, this particular hospital environment has, 121,000 total devices, out of which there's about 4,200 which we classify as IoT. And of course, the classification of IoT is also one of these gray areas. Is an Apple Watch an IoT device? Maybe not, right? Right? But I'll get into that. Just really quick, high level. I'll get back to sort of abnormalities and kind of how we look at that with each of these different device types. But just at a high level, these are my wireless, these are my wired. I'll get back to a little bit more information around this dashboard because it has to do with there's a bunch of data here around segmentation and what kind of devices are sharing SSIDs and VLANs and whatever else. But let me start with inventory. So what I want to show you guys here is the full inventory of devices. Let me zoom in here so you guys can see. Right, so this is an example of kind of what we've seen in this environment. So, we typically, either we're already deployed there or, a new customer or whatever it is. You put us in and we start learning what the IoT devices are in your environment alongside the entire list of devices and exactly what's going on.
You're classifying phones as IoT?
So these are IP, so SpectraLink, Cisco phones. Yeah, I mean, again, it's back to the gray area, right?
Okay. I was surprised to see those there. Yep.
Yeah, fair point, right? So, an iPhone we would deem not an IoT device, but, an IP phone. There you go.
Okay.
Maybe it is. All right.
If you say so.
Come on, man. Use user devices. But, then there are like some less sort of controversial, like EKG machines or pedometers or telemedicine robots, conference room equipment. We see a lot of that. And that's, even in regular enterprise, it doesn't have to be healthcare or manufacturing or one of these verticals. And then, as I sort of called out earlier, if I scroll all the way down here, you kind of see, especially on the onesie twosies, right? Like this Ford car connecting to the network, right? You see things like a smart home device, a digital photo frame or whatever it is, right? And you see these things, there's a healthcare network or whatever. You wouldn't expect to see some of these things, but they're there. And that's the big part of sort of inventorying and getting some insight into sort of what exactly is on this network. And sort of, there's the Tesla, right? That's on this network. A Raspberry Pi is on this network doing something, right? So yeah, you see these really interesting things, and then you can kind of subset from a customer perspective as to, okay, well, I don't care about the performance, of this Sharp TV or Tesla or whatever it is. I care about the performance of my infusion pumps, my EKG machines, and things like that. But I do want to know what are these other devices on the network. So that's kind of the first step, sort of inventorying, as I was kind of sort of talking about earlier. The next thing I want to kind of talk about is performance and connectivity of these IoT devices, right? And so one of the things is, as we sort of extend the platform, is segmenting the platform too. So we have the notion of sort of a network engineer role, a security engineer role, a help desk user, where sort of like it's role-based access controlled because the platform is so broad that, what do you call it? Certain roles shouldn't sort of, will get distracted by certain things in the product. So what I'm going to do is I open up a different role in another window. This is the network engineering role. So this is typically how I would sort of, this is the same general hospital. I'm just logged in this window as a network engineer. And basically, this is the view that you would typically start off with in this hospital, right? So where you're seeing all of the different sites or whatever. Well, you can't, see them on the map or whatever. They're there somewhere in the U.S. They're there. You're seeing sort of an incidence view across all of your different sites where this is just now about performance and client experience, where you're seeing, okay, at this particular Brookdale site, we automatically learn the baseline for DHCP, but now all of a sudden we see sort of a big deviation in DHCP client experience. And of course, this is across all clients, not just IoT. But what do you call it? That's what we're seeing. That's why we're calling it out. On the performance side, you'd sort of get insight into which sites of mine have the worst performance. You'd also get things like, just really quickly, I think some folks haven't seen it. Sort of dive in here. This is just from like a DHC, like any kind of metric or whatever. Forget deviations from the baseline. Just organize all my sites by where's the worst client experience, where's the best client experience in my sites. Right?
The metrics, show the list of metrics.
Oh, sure. Over here? Yeah. So yeah, so you can kind of switch this around and see different aspects of it, right? We're sort of on anything. The one other thing I'll just really quickly show you on the dashboard. If I dive into a particular site, one of the big sort of value adds on the client experience side, and something that sort of directly ties back to the types of algorithms we've been running on the client experience and performance side, has been this notion of recommending actions, right? So basically the way to read this is, hey, we think you should take this action. Co-channel interference on 2.4 gigahertz near this particular access point. And you can open this up and kind of see additional data around it, but let me just close it up for a moment. But this number over here is our notion of, we predict that this is the bang for your buck that you're going to get out of it. So one client having bad experience in 1 hour is 1 client hour of bad user experience, right? And in this particular case is on wireless. And in this case, what we're saying is 3199 client, by solving this issue near this particular access point, you will get back 3100 client hours of bad user experience on Wi-Fi. This example over here, servers taking a long time for DHCP offers. Sorry, actually, I don't know why it looks so bright. That's why I'm trying not to open it. Basically, we're saying, hey, on VLAN 260, in this particular case, servers are taking a really long time to give back an offer when clients are sending DHCP discovers, right? And if you can alleviate that, there are 1,200 client hours of really, really slow DNS that you can get back, right, by taking this action. So this is kind of just at a very, very high level, right, sort of where a network engineer would start, right, in terms of seeing all their sites and so on. But then the next,
So real quick,
yeah.
with this UI, with the maps and everything, I'm assuming that all these notifications may show up as a heat spot on the map.
Exactly. Probably not the DHCP one because a VLAN doesn't have a geographical location, but anything like these two or whatever that have access points associated with them and location in some sense. This view is sort of like the campus. There's an additional, if you dive into if these guys don't have it defined, but you can define floor maps. Mm. And so if you go into a floor, you can see it sort of laid out on the floor. Oh, this is where the clients are that were having that problem. This is where the clients were that were having this other kind of problem, and so on.
And can you drill into this and say, this is why the problem's occurring for this specific VLAN, or?
Yeah, perfect, right? So let me use this one, because also what I'm going to do here is I'm going to tie into IoT as well. So let me view this. So once I click on this, it's basically taking you to a power user page, right, where you want to drill even further into this particular issue. So this is, the St. Joseph's Hospital or whatever. So let me click on this and kind of show you what's going on here. So what you're looking at over here is this, as I said, so be prepared. It's a fair amount of data. So the metric selected over here is DHCP. So I'll just open this up so you guys can see. You can select any metric, and there's different kinds of analysis, like wireless, radius, DNS, DHCP, et cetera, right? So that's the, applications, Wi-Fi calling, GoToMeeting, Salesforce, and so on, right? So lots of different metrics that you can go and analyze. But because we drilled in from the dashboard, and specifically from a recommendation that said, hey, if you alleviate this problem on VLAN 260 in terms of servers taking a long time to respond to offers, then you get this 1,000 client hours of performance back. Basically, what it's done is it's taken this particular page and it's zoomed us into selecting a few filters here. So one filter selected here was the root cause, right? So the root cause being servers taking a long time for DHCP offers. And then the other filter selected was VLAN 260. So down here is the second filter selected. And given these two filters selected, one of the drill downs is, okay, well, now that I've sort of filtered that down, who are these clients? And should I care about these clients? And maybe that should be the next step of my drill down. So over here on the left, so there's all these different categories of things. These are sort of like buildings, you could say. What buildings am I seeing this problem more so in? This is DHCP servers, so which servers are sort of contributing to the problem the most? Over here on the left is which device models, right? So if I open this guy up, this sort of tells me the different device type models that are being affected by this particular problem. Most of these are phones, right? So these are just general user devices or whatever. I'll show you guys an example where they're IoT devices. I don't think in this particular case they're IoT. But closing that up though, if I scroll down over here, there's also a final view here around client devices. And if I open this up, basically we made this high-level recommendation, hey, you should fix this particular problem on this particular VLAN in this particular hospital, and we think you'll get this benefit. These are the exact clients that have that problem, or that we've seen that problem happen. It's all anonymized, that's why they don't look like real clients, but otherwise what you'd actually see are sort of the username and host name and stuff like that of the client devices. And so this would be sort of the next step to kind of drill down. But what I want to show you guys though is if I clear all of these filters, and actually let me open up a bigger set. So let me just do overall, so that we're looking across all the different devices across all of the hospitals, right? And if I do that, what I want to do here is exclude the guest network, right? So over here, these are SSIDs, and so I'm basically going to hit exclude here on the guest, right? Because I'm going to say, okay, let's not worry about DHCP issues on the guest network. Those guys are just visiting, and so let's focus in on non-guest. And then I'm going to open up this model view over here. So we're looking at DHCP issues, which are obviously connectivity issues. Like, can these things even get on the network? Are they getting on quickly, right? Is it failing at the discover side? Is it failing at the request to act side, or various things? And now that I've eliminated the guest network, we start to see sort of devices that I probably care a lot more about from a performance and connectivity standpoint. So I see, the phones, which, maybe you might or might not, but I see infusion pumps here. That's definitely something I care about, right? When they're not able to connect. I see, these Gajema devices are basically the systems that do specimen collection in hospitals, right? So cultures and whatever, and for testing. That's very important, obviously, right? If that thing can't connect, then that's problematic.
It looks like the way you've got this listed is, but by that percentage metric, is there a way you could have it by device type as being, like, presumably a medical device would be more important than?
Yeah, so the way we have it here, it's kind of all together. So it's like across all the clients, it's the percentage of the time that the device type has been on the network. And the filters so far are sort of more so like, hey, let me exclude these kind of networks and these VLANs and things like that. It is it's a good point that probably going forward as we get more deeper into IoT in specific, we probably just have a filter to say, I only want to look at IoT devices in this view and focus on their issues. Although even there, then we'll put a Tesla in there, and people put, I don't care whether this Tesla can connect or not or whatever, right? But
however, one of the things the platform does do is you can set up VIP groups. If you care only about certain kinds of people, CXOs or what have you, or certain kinds of devices, you can actually create VIP groups to just track behavior and security of those devices as well, and use that as a launching point to triage.
Okay, so if I was very concerned about medical device connectivity or whatever, I could make a group for that.
You can make a group for that as well. Exactly. Yep. Exactly. So what I was going to do is, okay, well, so given that this popped up, let's use these or whatever. Excuse me, and say, okay, I want to focus in on. So we're DHCP issues. We excluded the guest network. Let's focus in on this particular, these specimen collection device types, these Gajemma device types. And then, the rest of this all filters or whatever it is. And what you get down here is, as I said earlier, is sort of like the full list on what are these exact clients and, how often are they having the problem and who's the most sort of problematic of them, right? And so now you can sort of continue your deep dive, pick one of these or whatever it is, and sort of say, okay, what is going on with this client? I want to dive deeper into this, right? And so you get to a page we call the client details page. And again, so I'm looking at this from a networking perspective, and I'll show you guys what this looks like from a security perspective next, right? But what you're looking at over here is these are all the attributes of this particular client. One thing that's interesting is, so you see 10 values here. So if I open any of these fields up, this tells me that this device doesn't really play nice with DHCP or whatever it is, right? Because you would think that a device, shouldn't be getting this many IP addresses or whatever, unless they've set the lease time very, very low on this network. But that's a lot of IPs. But it's showing sort of now as well as historic. It shows you, okay, this is the DHCP server he's on. But if I open this up, he's sort of talked to both of these different DHCP servers. Over time, and so on and so forth. And you can kind of see sort of how he's been traversing. I guess this is the reason he's got 10 IPs, because he's been on 10 different VLANs, right? But anyway, so that's sort of high level information. Down here in the middle is something sort of is where we kind of summarize all of the incidents that we've seen for this client, and we were focusing on DHCP. So I'll just click on DHCP. And what we see over here in terms of root cause for this client is, okay, well, we've seen it happen, 5 times or whatever in the past week. A lot of this is our guess, right? Either there's a lot of conflict checks, that's why the offers are taking a long time to come back, or maybe it's overloaded. Down here, you can kind of see information around, well, the access point that of the similar models, like the specimen collection models, when this device was having a problem, were other specimen collections devices having the same problem? And it turns out not. It's just 1 out of 8. So this one, might be more problematic than others, and so on. There's another kind of DHCP issue that's sort of shown here, which is the fact that this client has actually had instances where it couldn't even connect to the network. So this one is more focused on latency, right? As in it's just taking a long time, but it actually got to the network. This one is, hey, we gave this device like 5-10 minutes, and it couldn't connect. And it failed at DHCP for whatever reason. So over here on the right is what we call the event timeline, and it contains every single connectivity event that this client device went through. So on this connectivity thing, if I wanted to view the evidence here, or whatever it is, of where exactly this happened, it's not quite that one. It's this one over here. So we see that at some point, at 11:23, at 14 seconds, the server rejected this client's request for the address, right? And what we'll sort of see up here is that that happened at 11:23, but by the next time this sort of device even tried was 6 minutes later. And actually, because this is filtered, it's not showing sort of the web-connected events, right? So we also detect when the client is able to successfully connect onto the network. And that didn't happen for several minutes. So basically, what you're tracking here is, okay, so this is an IoT device that I care about. It's been having these DHCP issues on the latency side. And it's also even had issues where it's just hasn't been able to connect, period. And that's persisted for several minutes. So if you now can imagine sort of the implication of that, it's basically that operations or whatever would have been stopped until this device could actually connect, right?
So do you mind if I just shift us just a little bit? So
Sure.
if I'm evaluating some of these devices and I
Yeah.
see an IoT device and I see it as abnormal,
Yeah.
and let's say a chief or a CXO brought this device in, you could find yourself in a real pickle of, going and shutting down their device.
Yep.
Based on information that you get out of here, not knowing kind of the context behind it.
Yeah.
Or is it possible that a device can be misidentified?
No, we have the devices right, and even in cases where it's doing the worst things on the network. So what I was going to get to next is sort of from the security side, what these devices' behavior looks like, who exactly they're talking to, are those things problematic and abnormal and things like that. And even if you've got all that right, you've got this device dead to rights that it's doing something terrible, you're absolutely right that we can't just blindly go and take the device off the network or something like that, right? It has to be done with the context of you know your environment, what can be done. Maybe this device is involved in some really critical medical procedures or whatever it is, and you have to wait for that to finish or whatever it is before you can address the problem. And so absolutely, that's that sort of context that needs to be added to this.
There was alerting and all that kind of thing based on certain thresholds and stuff?
Oh, definitely. Yeah. We try to minimize the alerting based on, again, machine learning of like normal, abnormal. It has to be this abnormal to constitute an alert, but people can go and change that as well. They can say, I want this device type or this device class or problem type to be so sensitive that just send me an alert immediately.
Can it hook into, I don't know, ticketing systems or?
Yes.
Yep, exactly.
ServiceNow.
Yeah, ServiceNow is sort of the most
It will
popular
actually
one that
create a
we see.
ticket.
Yeah.
You can define what kind of alerts you want to be to come to you across almost any dimension. So any deviation from normal. If it deviates more than 2%, if DNS deviates more than 2%, or if Wi-Fi deviates more than 10%, I want to know that, and you'll only get alerted on that. And then if a trouble ticket needs to be generated, we can integrate directly with, for example, ServiceNow, and it will send a trouble ticket to service desk guys so they can have all the client information right in their hands.
Yep.
And it will populate ServiceNow for that purpose.
So I guess the last question I would have on that, do you have different panes of glass that you can show to different, maybe an executive summary or
Definitely.
like me that need to get in
Yep.
and look at all the bits and bytes on it?
Definitely. So there's a whole section on reporting as well. Usually for executives and things like that, it's reports. They don't tend to log into the product. But even for people who do log into the product, I've switched my screen again back to the security role that I was in before, so that now you guys can see from a security side. So we've talked about inventory and we've talked about sort of performance and connectivity, right? Now we want to get into, okay, what is actually going on with these devices? So, over here, we just kind of summarize abnormalities. I'll just kind of give you a little bit of a tour here. I also want to keep an eye on time. When we say something is abnormal, the way we look at it is, so for instance, saying these GE, 16 of these devices are behaving abnormally, what we're saying is one of three things. Basically, one thing is, okay, there's 300 of these devices as an example, and they, 284 of them behave a certain way in terms of they only, on average, talk to like 10 external servers and 5 internal hosts or whatever it is. And they don't really deviate much from that. But these 16 behave very differently from those other 284 or whatever it is. That's one type of abnormality. Another type of abnormality is this device, these 16 devices themselves have been behaving a certain way in the past. And now all of a sudden they've changed their behavior and changed it in a way that we think is kind of abnormal, right? And then the third way is that these devices are talking to something external, right? Some external host, and one of those hosts that they're talking to has been deemed by a threat intelligence database to be a threatening external site. Maybe it's a command and control site, or maybe it's a site that's sort of had infections in the past and so on. So those are the kinds of abnormalities that some of them, it's like a matter of learning and seeing deviations. Other ones, we're sort of getting some insights from third parties as well.
Are you guys working with any of those large vendors for those larger IoT vendors to build a shim specifically for them?
Like a GE Health and
Yeah,
for some of the GE devices.
Yeah.
We've
Or even
worked-
like an autonomous car, right? That,
right.
If you're driving, I'd hate
Yeah.
to have some kind of vulnerability that would cause me to crash, right? That'd be bad.
No, fair. You've got a great point, actually. We haven't worked with them on the security side yet, right? We've worked with them on the performance side.
Okay.
Not with the, yeah, right. So that's basically it. But absolutely, going forward, we will be working with vendors to sort of add to that. So the next bit of visibility is just, these are, a selection of like some of these devices. If you just hover over this, it just kind of tells you what they're doing on the network, right, from a protocol and application access perspective. So just kind of hovering over these X-ray machines, that's what they're doing. The Alexa over here is doing a lot more on the network, right, which you'd kind of expect, and so on. Sort of that gives you that insight. Down here is sort of the segmentation insight that I was kind of alluding to earlier, which is that, okay, these are my SSIDs and these are my VLANs. What is on my health SSID? Right? And you kind of get a full list over here of IoT devices on my health SSID. You get a full list of IoT devices that are on my guest SSID. And then you look at this and you say, okay, well, wait a minute. Is something critical of mine on the guest SSID? Or vice versa, is something that shouldn't be there on my voice SSID or on my health SSID, and so on. Same thing with VLANs, right? Just to make sure that your segmentation policy is kosher with respect to how you kind of set it up. So that, and then there are a bunch of other information here. The next thing I was going to do is, let me do it from here, but actually I guess I could have done it from the other side, is on this view, the inventory view, you also get a view of how many internal hosts versus how many external hosts that they talk to as a group. And so you look at this and you can kind of see which ones are sort of more predictable and which ones are less predictable, right? So infusion pumps are very predictable, as I said. Across 1,100 of these devices, they're talking to 46 internal hosts and 0 external hosts. They're completely cut off, which you kind of hope and expect, right? So the minute, if we saw these things start to do anything deviant from that, or say talk to some external host that they weren't talking to, or join some VLAN that they never joined before, that's kind of a problem. And on that point, if I click in on this, you might say, okay, what are those 46 hosts or whatever, and when did they talk to them? And basically what you're seeing over here is that, across all of these different areas or whatever, I can see exactly which hosts across which protocols and things like that this thing talked to. I can sort of filter this list to say, oh, well, wait a minute, this is strange. When did it talk to this on radius or whatever? The graphs kind of filter below and so on. So this is kind of like the characterization as well as sort of the who, what, where, when on these devices. The next part of this, scrolling down, these are all the client device. These are all the devices. All the way down here are just some stats. One interesting stat is the number of active devices. And in some cases, we've kind of gotten these use cases. I alluded to it earlier around, hey, tell me how many of these things are actually being used on average, right? So there's actually two views, there's another sort of perspective of, hey, how many of these 1,100 devices have ever been active in the last X amount of time? This one is how many are active on average at one time. So, even at peak or whatever, there's only around 375 of these or whatever out of the 1,100 that are actually doing something at any given moment in time. The final thing that just kind of want to quickly show you from sort of again, the security side of the house is that clicking in on a single client now, so now that I'm in a security role, it's not about incidents or anything like that. Now, some of the information from even the performance view is still relevant, right? Obviously, I want to know what IP address is, where this client has been located in the past, right? As in, maybe this client should have been static in certain area, but it's moved around for some reason that we don't know. Maybe it's talking to some servers or something like that it shouldn't be doing. I want to know the same thing with the event timeline, every single event that this client has gone through. And then finally, I want to know, sort of scope just to this single client, exactly what is it talking to, when did it talk to it, and so on, as well as details around why it was potentially deemed abnormal or anything like that. So, just so hopefully, kind of, I've given you, kind of keeping an eye on time as well, but hopefully I've given you an idea that basically the way we view IoT, and we think that IoT should be viewed, and we've seen it from customer requests of us, right, around use cases, is a full life cycle that starts from sort of inventorying these devices, characterizing any kind of connectivity issues that they go through, and performance as well, in terms of just making sure that they can even perform their function that they are supposed to perform. Then you get to characterizing their behavior. Then you get to sort of detecting abnormalities, and then taking security actions, but in context, sort of with the IT and with security folks. And then finally, sort of verifying microsegmentation, segmentation, and compliance in terms of making sure everything sort of adheres. And the other part of this is sort of the fact that all of these kind of fit in one spot for IoT, right? I wouldn't make this claim for sort of general client devices. I wouldn't say that, hey, network analytics should tackle the problem of securing your iPhone or securing your laptop or whatever it is, just because security is a lot broader than just that. But for IoT devices in particular, again, because you can't put any agents on these things, a big part of IoT security is securing their behavior and figuring out what they can do, when they do it, and detecting deviations.
And given that we're vendor agnostic and defining security policy is different from how one company secures a group of devices or users is really different. Do they use a firewall? Do they use ACLs? Do they use VLANs or what have you? Where it becomes interesting is how do you use this data to now automate enforcement? And once we start, with the integration with things like ICE and ClearPass and Palo Alto firewalls and checkpoint firewalls, we get a view into exactly, okay, what is the policy? And when does that device and its behavior deviate from that policy so that we can actively allow you to enforce it given whatever security posture that you've set in place? And the problem is, there's good news and bad news. The good news is that we look at a ton of data. The bad news is that we look at a ton of data. And doing stuff with that really requires an understanding of what your security policy is. And sometimes security policy is set by one group, and in other companies it's set by another group. This helps kind of codify the data, because the data is real, whether or not you're the security guy or the network guy or you're the help desk guy. So the platform allows you to kind of have a single source of, again, truth that allows you to set in place policies for enforcement, policies for behavior, policies for monitoring and management, whether that's an IoT device or any other device on your network. And we find that's really useful because you're not tied to any one vendor trying to force fit down your throat. Here's how you would secure an IoT device or any other device given our product, because you might have a different way you want to approach it given the makeup of your organization. I don't know if that makes sense, but
right. But do you subscribe to any threat feeds out there so you can alert customers, hey, your traffic is actually matching patterns that we've already seen? We've already been notified on these threat.
Definitely. In multiple ways. One way is sort of just integrations with third-party threat feeds and threat databases. The other way is cloud sourcing, right? If we've seen a problem happen in one spot, we can make an advisory for all our customers that this is something we've seen in terms of this kind of misbehavior. So, yep. But yeah, I just wanted to open it up for any thoughts or questions from you guys.
My question on that, follow-up on that would just be like, how do you take an action on that? If you're integrating with the Palo Altos and checkpoints already, is there something that you can do on their point, or can you trigger an action in ClearPass to shut a port, or?
Yeah, so they have APIs.
But are you actively communicating?
Yeah, via those APIs, exactly.
Yeah, okay.
But it's not automated.
Okay.
We don't sort of automatically take the action order, just precisely because of the point that you mentioned earlier,
right,
which is that we don't have the context as to, well, wait a minute, are we taking an infusion pump offline?
And you really get a pickle in that case.
Exactly, exactly, right? So any action being taken, we can take it from the platform, but it has to be taken by the administrator who has the context. right? So that's part of it. But the integrations are more so, a really good example is Cisco ICE, so similar to ClearPass, right? Where they have an open standard called PX Grid. You can both read data off that open standard from ICE as well as write to ICE in terms of policies or in terms of even indicating that these are IoT devices that we've detected and so on. And so we use that API in both directions to be able to talk to it. But again, the final sort of press the red button, if you will,
Right.
is done with context.
Okay,
Yeah.
thank you.
Yeah, no problem.